Good morning, grade 10. This video will discuss the answers and solutions of the Electrostatics standardized test question paper given to you. This is Ms. Teresa. Question 1. How many electrons have been removed from a positively charged electroscope if it has a net charge of 7.5 times 10 raised to negative 11 coulombs? So in this problem, we would need the equation Q is equal to N multiplied to E, where Q is a charge measured in coulombs and E is the charge of one electron, and N is the number of electrons. And according to studies, one electron has a charge of 1.6 multiplied to 10 raised to negative 19 coulombs. This value is also found in your textbook on page number 62. So applying the formula, Q is equal to N times E, where Q is given as 7.5 times 10 raised to negative 11 coulombs, and the charge of one electron is this one. We're going to look for N. From this equation, N is equal to Q divided by E. So substituting, we will have Q as 7.5 multiplied to 10 raised to negative 11 coulombs divided by 1.6 multiplied to 10 raised to negative 19, and you will get the value using your calculator of 4.7 times 10 raised to positive 8 electrons. So the answer for this question will be letter D. Letter D, let me just circle that. D. So this is our answer. Question 2. The force exerted on a particle with a charge of 5.0 times 10 raised to negative 9 coulomb by a second particle that is 4 centimeters away is 8.4 times 10 raised to negative 5 Newton. What is the charge of the second particle? In this problem, we are looking for the charge of the second particle. This is the first given, which is measured in C, and if it's measured in C, we know that that is a charge, so that will be our Q1. Q1 is equal to 5.0, let's just list that, times 10 raised to negative 9 coulomb. The second given is 4 centimeters. If it's in centimeters, it means that it is distance. So in our Coulomb's law, because this will be applied, this law will be applied in this problem, which is F is equal to K Q1 Q2 over R squared. The distance over there is the R. Therefore, R is equal to 4 centimeters. It's in centimeters, therefore we have to change it into meters. That would be equal to 0.04 if we divide it by 100. And then we have another given, which is this one. This is measured in Newton. The SI unit there is Newton. Therefore, that will be the force. F is equal to, in the problem, it's 8.4 times 10 raised to negative 5 Newton. And of course, we have in our formula the K. K is the constant 9.0 times 10 raised to 9 Newton meter squared over C squared. We are looking for Q2. So if we're going to manipulate this formula and obtain the formula for Q2, we'll be left with Q2 is equal to F R squared divided by K Q1. So substituting, we will have 9.0 0 times 10 raised to 9 for K. No, that's wrong. Okay, I'm sorry, that is like F. Should be F first. Sorry guys. Okay, 8.4 times 10 raised to negative 5 multiplied to the R. The R is 0.04, and it should be squared divided by K is 9.0 times 10 raised to 9, and then Q1 is 5.0 times 10 raised to negative 9. Alright, using your calculator, you'll be getting the value 2.99 times 10 raised to negative 9 coulomb. But we are going to round it off to two significant figures, so we'll be left with 3.0 times 10 raised to negative 9 coulombs. And that is letter C from our choices. Question 3. Three charges A, B, and C are in a line as shown below. What is the net force on charge B? So as you can see, we have a drawing here, and the charges are in a line. Then we're going to get the net force on B, on charge B. So each of the each of the charges are given over there in the drawing. So this problem is actually an application of Coulomb's law, which is F is equal to K, Q1, Q2. You can change the subscripts of Q's. We can use A or B or C according to our problem, divided by R squared. So first and foremost, we're going to solve the force of charge A on B. Force of charge A on B is equal to K, which is 9.0 times 10 raised to 9 multiplied to the charge of A, 8.5 times 10 raised to negative 6, and multiplied to the charge on B, which is 3.1 times 10 raised to negative 6 as well, divided by the distance between them, which is 4.2 centimeters. If we're going to solve the 4.2 centimeters and change it into meters, that will be equal to 0.042 meters, and you have the square. Please do not forget to convert the units from one to another. You have to always use the SI units for each of the problems. Okay, so if we are going to solve this using our calculator, the force of A on B, F of A on B, will be equal to 134.44 newtons. So if we are going to draw that, this is charge A and this is charge B, then this is charge C. Later on, we're going to solve for the force of charge C to B. So we have solved that. The force of charge A to B is equal to 134.44. Okay, so 134.44 newtons. And then we're going to solve for the next one, which is force of, we're going to use the black one so we can distinguish between the two, force of C on B. Okay, so still the K is equal to 9.0 times 10 raised to 9 multiplied to the charge of C. The charge of C in the given is 6.4 times 10 raised to negative 6 multiplied to the charge of B, which is still 3.1 times 10 raised to negative 6, divided by the distance between them, which is still in centimeters, converted to meters, so it'll be equal to 0.029, and do not forget the square. Using your calculator, the F of C on B will be equal to 212.32 newtons. So the force of C on B is equal to 212.32 newtons. It means that in this case, it means that the charge C is pushing B towards this side with a force of 212.32 newtons, whereas A is pushing B towards the right with a force of 134.44 newtons. So obviously we know that this is greater than this value. So if we're going to get the net force of this, they are of different directions, so you're going to get the difference between 212.32 and minus 134.44 newtons. So if we're going to get the difference of that, it will be equal to 77.88, and if we round it off, it'll be 78. But what's the direction? Okay, so the direction is basically this is a larger number, therefore it has a greater push than this one. Therefore, the answer will be 78 Newton towards A. So this is our answer, letter A. Question 4. What is the charge on an electroscope that has an excess of 4.8 times 10 raised to 10 electrons? Again, this is a problem which Q is equal to NE will be used, where 4.8 times 10 raised to 10 is our number of electrons. So that will be 4.8 times 10 raised to 10 electrons. Okay, and E is still the charge of one electron, which is equal to 1.6 times 10 raised to negative 19. This is always the same number for E, coulomb. Okay, so we're looking for Q. Q now is equal to N, which is 4.8 times 10 raised to 10 electrons multiplied to E, which is 1.6 times 10 raised to negative 19 coulombs. So using your calculator, you'll be able to get the number 7.68 times 10 raised to negative 19 coulombs. And then if we're going to round it off to two significant figures, we'll get the number 7.7 times 10 raised to negative 19 coulombs, which is letter C in our choices. Question 5. Two charged bodies exert a force of 86 Newton on each other. If they are moved so that they are 6 times farther apart, what is the new force that they will exert on each other? So this is also an application for F is equal to the Coulomb's law. F is equal to K Q1 Q2 over R squared. But in this case, the force is already given. F is equal to 86 Newton. But then we're going to change the distance between the two charges from R, and it'll become 6R. Okay, so we know that F is equal to KQ1 Q2 over R squared. The F is already given, so 86 is equal to KQ1 Q2 over R squared. So this part of the equation, this part, is already equal to 86. But now we're going to change the distance between them from R to 6R. So therefore we are going to have a new equation. The new force will be equal to, new F is equal to KQ1 Q2 over 6R squared. So this will be equal to KQ1 Q2 over 36R squared, right? But we already know that this part of the equation, so this one, as we know, is already equal to 86. Okay, so what does it mean? It means that we are going to just multiply the new f. The new f will be multiplied with this factor, this factor, which is actually 1 over 36, multiplied to the 86, the original force. So if you're going to multiply 1 over 36 times 86, you'll be getting the number, what's the number? Wait, please. Let me just calculate. So you're going to get the new f as 2.38 newtons. Okay, but we're going to round it off, of course, to two significant figures, which will be equal to 2.4 newtons. And that is answer letter A. Question 6. Two equally charged bodies exert a force of 90 newtons on each other. If one of the bodies is exchanged for a body of the same size but 3 times as much charge, what is the new force that they will exert on each other? So this problem is similar to problem number 5. We're still going to apply the formula F is equal to KQ1 Q2 over R squared. Now we are now given the force, which is equal to 90 Newton. In the previous problem, we changed the distance between the two charges, but in this case, we changed the charge of one of the charges. Let's say Q2. We changed Q2 into, how much is it? 3 times as much charge. So it means that Q2 will become 3Q2. Now from the problem, it says that the F is equal to KQ1 Q2 over R squared. The F is already 90 Newton. Okay, so it means that KQ1 Q2 over R squared is already equal to 90. Okay, now if we're going to change one of the charges to 3Q2, so this equation, the new F will become KQ1 multiplied to 3Q2 over R squared. So we need to simplify. So just put the number before the variable, so it'll become KQ1 Q2 over R squared, which is the new F. Okay, but we already know that this KQ1 Q2 is equal to 90. So just multiply that 3 to the number 90. So our new F, new force, will be 3 times 90, which is equal to 270 newtons. So the new F is equal to 270 newtons. Is there 270 newtons in our choices? It's not there, but actually it's equal to 2.7 times 10 raised to 2. 2.7 times 10 raised to 2 newtons. Okay, in scientific notation. Question 7. An alpha particle has a mass of 6.68 times 10 raised to negative 27 kilograms and a charge of 3.2 times 10 raised to negative 19 coulombs. What is the ratio of the electrostatic force to the gravitational force between two alpha particles? This is quite tricky because we need the formula for gravitational force as well, which is similar to electrostatic force actually. So the electrostatic force formula actually is equal to it's Q1 Q2, we know, but in this case we are only dealing with one particle, an alpha particle. So instead of Q1 Q2, we'll just have to square that. Okay, Q squared divided by R squared. And now we are going to have another formula, which is the gravitational force, which is equal to Fg, and that is equal to G m, there's only one particle, so instead of m1 times m2, we're just going to square the mass divided by r squared. So as you can see, the formulas are similar. Okay, now we are being asked of the ratio between Fe, the electrostatic force, and the gravitational force. It means that we are going to have Fe divided by Fg. Okay, we know that K is equal to 9.0 times 10 raised to 9. Now how about G? G is also a constant. You can find the value of G in the internet if it's not in your calculator already. If you're going to have this in your exam, the value of G will be given as well. So I'm going to give you the value of G, which is equal to 6.67 multiplied to 10 raised to negative 11. And there's a series of units for this as well, but we just need the value, so I don't want to write the units. We don't have space. That's the only reason. Okay, so we're going to simplify. Here, the formula for Fe is kq squared over r squared divided by, the formula for Fg is gm squared over r squared. We have same denominators for each, therefore we can cancel r squared for both, and we are just left with the formula Fe over Fg is equal to kq squared over gm squared. Okay, now we're going to substitute numbers for this. Let's use the smaller pen. The k, we already know the value, which is 9.0 times 10 raised to 9. What is q? In our problem, the q, the charge is 3.2 times 10 raised to negative 19, and we're going to square that. Square because of the formula. Divided by g. The g is this one, 6.67 times 10 raised to negative 11 multiplied to the mass. The mass given is 6.68 multiplied to 10 raised to negative 27 kilograms. Alright, now if you're going to use your calculator to solve the ratio between Fe over Fg, these are the series of numbers that you're going to put in your calculator carefully. Hopefully that you're going to do that. You're going to come up with the number 3.09 times 10 raised to 35. Okay, now it's a ratio of two numbers, therefore you don't have a unit. Now if we want two significant figures only, 3.1 times 10 raised to 35 is the final answer, which is letter D. Question 8. Charging a neutral body by touching it with a charged body is called charging by, of course this is obvious, by conduction. Your clue will be the touching it with a charged body. How about if it's induction? Induction is you're just going to place the charged body near to a neutral body. Okay, so that's the main difference between conduction and induction. Okay, for conduction you're going to touch something with a charged body, and then for induction you're just going to place the charged body near to a neutral body. How about grounding? Grounding is a process when a charged object is grounded and the excess charge is balanced by the transfer of electrons between the charged object and the ground. Okay, so it's the process of removing excess charges on a body by connecting a wire basically to the ground. All right. Question 9. Macy rubs a balloon with wool, giving the balloon a charge of negative 8.9 times 10 raised to negative 14 coulomb. What is the force between the balloon and the metal sphere that is charged to 25 coulombs and is 2 kilometers away? Alright, so this problem is basically an application of the Coulomb's law, which is F is equal to KQ1 Q2 over R squared, which is now relatively easy for us. But you have to remember that if we're solving using the Coulomb's law, you don't need to include the negative signs for these charges. Alright, so we know that K is 9.0 times 10 raised to 9 Newton meters squared per Coulomb squared. And then we have, what else is given? Okay, that one. 8.9 times 10 raised to negative 14 is our Q1. Okay, let's just list negative 8.9 times 10 raised to negative 14 coulombs. Okay, and then Q2, as you can see over here, is 25 coulombs. How do I know that that is a charge? It's because of the C, the Coulomb unit. And 2 kilometers over here is our R. It's in kilometers, therefore you have to change it to meters. So 2 kilometers multiplied to 1,000, then we are left with 2,000 meters. Applying the formula, okay, and we are going to substitute the numbers now. K is 9.0 times 10 raised to 9. Okay, it should be inside, I'm sorry about this. 10 raised to 9, then multiply to Q1, which is 8.9 times 10 raised to negative 14, multiplied to 25 coulombs, divided by the R, which is 2,000. And do not forget that it should be squared using your calculators. Of course, it'll be equal to F is equal to 5.0 times 10 raised to negative 9 newtons. So relatively, it's a very small number because they are so far away from each other, which is 2 kilometers, which makes sense actually. And do we have an answer? Where is that? It's letter B. All right. Question 10. This is an extended answer. It means that it is a higher order thinking skills question designed for extremely talented students, which of course you are. Okay, according to the diagram, what is the net force exerted by charges A and B on charge C? In your answer, include a diagram showing the force vectors FA on C, FB on C, and F net. So this problem is a combination of Pythagorean Theorem, Pythagoras, as you know, and what else is there? Net force, and of course the formula, never ending, never dying. F is equal to K Q1 Q2 over R squared. In this case, we're going to use QA, QB, and QC for the charges. First and foremost, we need to know the distance between A and C because it's included in the formula. Okay, this one is actually how to solve for the distance between A and C. We're going to apply Pythagorean Theorem, alright, which is equal to C is equal to root of A squared plus B squared. Okay, so if we're going to apply that, okay, let me just highlight it for you. Okay, this distance is 0.3 and this distance is 0.4, which is equal to this distance 0.3, although in the negative direction, and of course we're going to use the same side, 0.4. It means that if we are going to solve for this side, it'll be equal to this side since they are of the same distances to each other. Okay, applying the, what's that again, the Pythagorean Theorem. Okay, so we know that C is equal to root of A squared. Okay, we're going to use A squared as 0.3 squared. Okay, let me do that again using a smaller pen so that we'll have space because this problem is quite long. Okay, let's solve for this side, okay, which is equal to the other side as well. All right. Okay, so C is equal to root of 0.3 squared plus 0.4 squared. So that distance is equal to, use your calculator, you will be able to get 0.5. There's no unit given in the problem, therefore we are just going to use 0.5. So the distance between A and C is 0.5, and this is also 0.5 because they are equal. Am I correct? Yes. All right, now what's the next step? Now we're going to solve for FA on C, force, electrostatic force of A on C, using this formula, of course. All right, so using that formula, let's use another color to distinguish between them. FA on C, okay, FA on C is equal to K, which is 9.0 times 10 raised to 9, multiplied to, the charge of A is negative 2.0 microcoulomb. Micro means 10 raised to negative 6, and we are not going to use the negative sign when we are going to solve for the F. All right, so 2.0 times 10 raised to negative 6 multiplied to the charge of C, which is negative 4. Oh, no, we're not going to use the negative sign. 4 times 10 raised to negative 6 because it's still micro. All right, divided by the distance between them, which we have solved, which is equal to 0.5. Now, looking at our given, this is also 2.0, negative 2.0. They are similar, and of course it will be directed to the same charge, which is 4.0, negative 4.0 microcoulomb. So it means that FA on C is also equal to FB on C. Okay, so whatever we get here, whatever value we get on FA on C, the first one, this one, will be equal to FB on C. So we'll just solve FA on C first, so that we will not solve the second one anymore because they are equal. Okay, so FA on C will be equal to 0.288 newtons, and don't round it off before you get the final answer because you'll just be in trouble if you do that. All right, so if it means that FB on C will also be equal to 0.288 newtons, right? Because they are same numbers. FA on C is equal to 0.288, and FB on C will be also equal to 0.88. Now, what's the next part of the problem? We're going to find the direction of the net force. Okay, so we know that this is A, okay, and this is C, okay, and then this is charge B, and now we were able to solve the net force of A, no, the force of A on B, no, A on C, I'm sorry about that. This is C, that is C, and this is B, okay, this is B. Okay, A on C, we were able to solve that it's equal to 0.288. So it means that this direction, the net force of FA on C is 0.288 newtons. Okay, and the force of B on C, this one, we're able to solve it, means that this is equal to 0.288 newtons as well. Now applying the concept on net force, the net force of these two forces F1 and F2 will be equal to this one. The direction will be this one. Okay, this is the resultant force, or F net. Okay, The F net, actually, we're going to outline this part and this part. It means that it still follows Pythagorean Theorem. Okay, this part and this part. So we'll be able to solve for this part using Pythagorean Theorem. This is 0.288 and this is also 0.288. Okay, now using Pythagorean Theorem, the F net is equal to the root of 0.288 squared plus 0.288 squared. So you'll be getting a number which is equal to, we'll just calculate, 0.288 squared plus 0.288 squared is equal to root 0.407 newtons. This is your F net, which is being asked in the problem. Okay, so that ends the video. Thank you for listening and thank you for solving with me, and see you in the next video.